Am I audible?
Yeah.
A very warm good evening to all. It's my pleasure to welcome all of you for today's section titled by Introduction to Astronomy and Astrophysics, organized by the Department of Mechanical Engineering in association with the IEEE Student Batch and Institution Inno- Innovation Council of Ahalia School of Engineering and Technology. The section is handled by Mr. Jayant Garguli, Senior Technical Officer, Regional Science Center, Calicut.
Shall I start?
And I welcome our speaker, Mr. Jayant Ganguly, sir, for the section. Welcome, sir.
Thank
I,
you.
I would like to welcome Mr. P.R. Sri Mahadevan Pillai, sir, Principal of Ahalia School of Engineering and Technology. Welcome, sir. I would like to welcome Dr. Krishnakumar Kishore, Vice Principal and IEEE Student Batch Council of ASET. Welcome, sir. And I welcome all the HODs and faculty members for the section. Finally, I welcome all the participants for this section. Welcome all. I would like to speak a few words about Jain sir. He is affiliated at the past 25 years to Regional Science Center and Planetarium Palakkad, which is functioning under National Council of Science Museum, Government of India. His main subject of interest includes astronomy and astrophysics, computer science, and related technology. He was authored several books individually and jointly included a on discrete mathematical structure. He has MSc, MCA degree. He has also purchased a graduate program on astronomy and planetarium science. He is AMIETE CSE and Executive Committee member of Institution of Electronics and Telecommunication Engineering for Calicut Subcenter. Once again, I welcome you all. I request everyone to mute your mics in the case of any queries. You can put it in the chat box. At the end of the section, feedback link will be posted. Only those who fill the feedback form will get the certificate. I invite Jane sir to take the section. Sir, it's all yours.
Thank you. First of all, I would like to thank the organizers from the Mechanical Engineering Department of Ahalia School of Engineering and Technology, who has organized this program and who has also invited me for delivering a talk on an introduction to astronomy and astrophysics. So I go to the my presentation mode. 1 minute, just a minute. I think we have to do it in presentation. Okay. All of you can see the screen, my slides. Can all of you see this right?
Yes.
Yes, sir.
Okay. So today's talk is actually on introduction. We will be we will be providing an introduction to this vast area of astronomy and astrophysics. And as I will show you, yeah, I have been telling you that this is not only for people who have a background in science. This astronomy and astrophysics are actually attracting a lot of engineers also as a part of their core team, because instrumentation is the core part through which actually a lot of detectors are developed, and a lot of engineers are also getting involved. So it may be interest to a broad spectrum of audience, and this will just provide you with an overview of what is the subject all about, what is the fun involved. In fact, after the maybe you already have, I don't know, you can have a astronomy club in your college, and you can have some astronomical observations with all these equipments, as we will be discussing briefly as I go through the slides. So sometime or the other, what happens is that when we are growing up, when we have passed through our schools and entered the colleges. Somewhere somebody might have shown us with a telescope and we shown us some object which is brightly twinkling or shining in the sky. Uh, Something, what are those objects? What are those stars? How they are scattered, whether there is something beyond that. So these are the questions which have baffled the minds of humans from all ages. We will be seeing that what are those and how actually our scientists, astronomers, astrophysicists unravel the mystery behind all these objects. So before we start into astrophysics, that is explaining the astronomical observations in light of the physics knowledge which we have gathered, we should first know actually what are the objects which we can see in the sky. That is very important because we should first identify those objects. So let us see what are the objects we can see with our unaided eye. We can't see many objects like very far distant galaxies you can't see. But then what all things we can see? This is a familiar sight actually. You can see a lot of stars. If you are in a city, if you are staying inside the city and you have a lot of air light pollution, then maybe the number of stars which is shown in this picture will be limited. Only the bright objects will be seen to you. But imagine that if you are located in a maybe Kerala is actually a good place because there is less light pollution in most of the cities. But still, if you are located in a remote area where there is much less light pollution, you will see much more stars. And ancient human civilization has seen a lot of stars because that time in long back there were no much air pollution there. And then they actually initially they wondered what are those gods. They thought about god, goddesses, a lot of religious things came inside. But ultimately, some logic erupted in their mind. Actually, they could see that there were some patterns. So before they could understand the pattern, they could see that they could, for understanding the sky, they have to make certain signposts in the sky through which actually they can find out whether any new object has come, whether these objects are changing or whether they are fixed with they are recurring. So that gave rise to a concept of constellations. So as you can see that here one area with some stick diagram, this is one constellation. So like that, people started seeing the sky from time and again. They went on seeing and gazing at the sky. In fact, this is one lab which is available to the people free of cost for a long time. And actually, this science, that is the science of astronomy, is the oldest of all science because people have seen this and it has been one of the most important science which has given the concept of month, the concept of time, the concept of means a lot of direction. All these actually are seen through the framework of the sky. So you can see here a lot of stick diagrams where people started imagining. There are a lot of figures and facts. Now their imagination is limited to what they can think. So we can think about, say, animals and birds which we see in our Earth, or we can actually imagine about some imaginary beings like humans wants to fly. So they thought of how not have a horse with winged horse or something like that, or half horse, half man. So their imagination was left open and they started thinking a lot of things in the sky, and myths and legends got formed and mythologies got created and they created stories in the sky. So connecting these dots. So like that, lot of figures got created in the sky. But then this went on for a long time. But then one problem occurred that we have actually that so many cultures are there throughout the earth, and they all started imagining different types of objects. Like you can see that there are somebody is imagining like a hunter, some horses are there, some rabbits are there, some snakes are there. So there I can think something as a hunter, somebody will think something as a something else like a giraffe or something. So there were clashes in their imagination. So then what happened is that then somebody actually should come into the picture and should make it more logical so that we get a framework. We will speak about it after some time. So stars are one of the objects which has conquered the imagination of humankind for very big period of time. People try to understand what is there. Is there any person staying there, or what are they? It is a separate world which we may not be able to find anything much about it. So this all went on for a long duration of time. Then let us leave the stars for the time being, and what other things we can see in the sky. So one of the things which we can see is our sun. So we should not see the sun directly, as you might have sometimes tried, and it is so glary that you may not have seen it. Sometimes maybe during your school days, some teachers of physics might have shown you a projection of that sun through a pinhole camera on the white paper, and you might have seen the image of the white light image of the sun, and maybe you have seen some dark spot on the image. They are the sunspots. So if you happen to be in some solar observatory or in some planetarium which have a solar telescope, you might have seen the sun using that solar telescope. Then you can see something more which you can't see using a white light image. You can see that there are rings, there is a limb around it, and then it is much fragmented, not a smooth thing. So all these things you can see. The sun is a very fascinating thing, and a full branch of astrophysics that is called solar astrophysics is dedicated only to the study of sun, because this is the star which provides us all the energy we need for survival on the earth, the temperature, the light, the energy. This is a very important star. It is a near star to our homely planet, the earth. So people are studying it, and if we understand this star, we can understand this our star, that is the sun. We can also understand other stars much better. So that is one thing. Then one more thing is that people started observing other things, like suddenly they saw that some black object like thing is crossing the disk of the sun. So this is called a transit. So people took some time to understand what exactly is happening, why this black, what is this black thing. Or sometimes they might have seen that a dark object is slowly covering up the sun. So initially the ancestors started actually thinking about demons eating away the sun, or God is playing a godly game by closing the sun, or some means switching off the sun or something like that, or people are angry. Some of our heavenly beings are angry with us. So all those things people started thinking, but ultimately wisdom dawned on them, and they started finding out that actually what happened is that the moon, which is our natural satellite, while going around, revolving around the sun, and due to its positional geometrical coincidence, in the sense that the sun is actually 400 times bigger, angular diameter of the sun is 400 times bigger than the angular diameter of the moon as seen from the earth, and also the sun is 400 times further than the moon from the earth. So these two coincides together to have a geometry, so that sometimes in favorable positions actually the moon exactly covers the disk of the sun. So we see a total solar eclipse. So wonderful sight. If you have ever a chance to see that, you should never miss it. So that is one more thing which we can see, a solar eclipse. And then actually people saw flares. They studied the sun using space telescopes, and they saw a lot of structures on the surface of the sun. As I was telling you, this is through projection. This is through very sophisticated space telescope and simulations. They understood what all things are happening on the live means time lapse image they can make, and show you that how exactly these arches are getting formed, and fire is, it is a huge fireball. So those things people started studying. And then if you are seeing the sun from any location, from your location also, if you go on seeing the position of the sun at a particular day, a particular time of all day throughout the year, you will get a figure somewhat like this. This is called a solar analemma. So this is solar analemma. This is due to our the inclination of the Earth with respect to its orbit, and so the projected image of the sun actually, as the Earth revolves around the sun, traces this particular uh, curve in the sky. So this is called a solar. These all things you can observe if you are a keen observer of the sky. Another very important and very interesting thing is moon. So we all actually, all of us, when we see the moon, we think about beauty, how beautiful it is. Imagine that when it is fully dark and the full moon is just above it, or just near the horizon, it is rising, it is big in size. It looks so beautiful. But then if you observe a moon through a telescope, when it is fully bright, it is very glaring. But just try to observe the moon when it is half bright. For example, half moon is there. So you will see that lot of interesting things are there on the surface of the moon. You will see that there are mountains, there are craters, and there are dark areas, bright areas. There are shadows of the mountain. Even where people have done project in our regional science center, Planetarium Calicut, whether they actually measured the height of the lunar mountain by actually measuring the length of the shadow and then making the corrections which are required. So moon is a fascinating means object, and people took time to understand that actually moon is somewhat like our Earth, devoid of certain features, like it doesn't have atmosphere. We do know that why it doesn't have atmosphere, why it's gravity, why people can jump much higher, or why actually there is no water. I mean, the people are finding no flowing water, or what is actually moon about? What are its geological features? So all these things actually people started understanding as they studied the moon through telescopes, as they made the impact landing on the surface of the moon, or as they made actually where people have gone and landed on the surface of the moon, and then they studied the lunar features. So these are some of the things. This is one of the objects which is very fascinating. And then there are other things, like there are planets. So we have this is the broad view of our solar system. A solar system consists of actually the sun and the planets and the comets and the meteors and all the dust particles and everything put together. Ions, all these things are a part of our family, which is called our solar sun family, or the solar system. Now this full family is divided into two parts: planets which are located between sun and the earth, between them, that is Mercury and Venus. These are called inner planets. And planets which are located beyond earth, that is Mars, Jupiter, Saturn, Uranus, Neptune. Now previously Pluto was also there, and because there were some reasons, now people have not declassified Pluto as a minor planet. No more it is a planet. So inner planet and outer planet. Then there are some planets which are rocky, like we have there are some Mercury is a rocky planet, or terrestrial planet it is called. Up till Mars, actually the planets are rocky. They are called terrestrial planet. Beyond Mars, actually they are gaseous planets. They are huge in size. They are mostly composed of gases. You can see that this is the biggest planet in our solar system. This is Jupiter, and you can see this Jupiter with this fairly good telescope, like 6-inch telescope. If you have access to that, you can focus it on Jupiter, or you can focus it on Saturn, and you can really see the rings of the Saturn, or the atmospheric patterns, and the great red spot. This is the great red spot, cyclonic storm on the surface of the Jupiter. So all those things you can enjoy seeing, but it took some time to understand actually. Thanks to Galileo, thanks to Kepler, who actually did a very painstaking work, and ultimately they came to the conclusion that these objects are actually moving around the sun. We are also moving around the sun, so it is a heliocentric concept which predominates. Copernicus actually suggested this. Before that, people used to think about geocentric concepts. So these are the objects which you can see in the sky. What are the other things which you can see? One more thing which you can see is the phase of the this Venus. This is the planet Venus. Now, this was the first proof. Actually, people thought, why should Venus appear as a crescent like somewhat of a moon? Moon is moving around us, so it may be a full moon or a half moon or something. But then why should Venus look like that? From that, they concluded that actually Venus is not moving around Earth; it is moving around the Sun, and we see it from different directions, and that is the reason we see the phases. So that was first proof that it is a heliocentric model, not a geocentric model. Then if you focus on Jupiter, as I was telling, you will see that there are small dots around that main central planet. Yeah, like this, you can see the dots. And if you go on seeing this particular planet for a period of time, you will see that the number of dots are changing with respect to their position every day, or so they're moving. So from there you will conclude that they are the moons of the Jupiter. Similarly, there are some planets which are classified as a morning or an evening star, Mercury and Venus, because they just appear before the sunset, or and just for a brief period after the sunset, or before the sunrise. So they don't appear in midday and all. So these are actually because they are the inner planets, that is the Mercury and Venus, and due to their geometry, they appear in that forms. So, and then further, when you see Mars, you will see the polar ice caps. All those things are very good to see if you're using a telescope, and they're quite interesting. Then one more wonderful thing happens, and you might have seen, sometimes you might have seen a streak of light passing through the sky. So if you see, and if you happen to be in a location, and there are some windows, there are some dates actually throughout the year where you see these streaks of light crossing the sky from a particular direction. So these are actually meteors. They are dust particles. When they enter our atmosphere, they get heated up and then they light up due to friction. From where these dust particle came? They came actually because as the comets move around, we will speak about comets, but as the comets move around, it leaves dust particle in its path, which due to gravity enters the Earth atmosphere. When the Earth crosses those orbit at certain period of time, because comet has gone, but the orbit stays there, and Earth passes through that orbit. So this is the picture of a comet. You can see a giant. You might have seen a comet. I am not sure, but if you have not seen, if any time if a comet comes, please go and see that. You will see that it is a magnificent tail system, and there are two tails. One is a dust tail, and one is a plasma tail. They are attracted towards the central nucleus, which is actually why gravitationally attracts as the comet moves throughout to around the sun, and either goes away or crashes on the sun or whatever it is, depending on its dynamics. What happens is that the scale follows it, and it is thrown out because of the radiation pressure from the sun. So all these things, it makes it a very attractive sight. So constellations, as I was telling you, that people started thinking about a lot of constellations, and ultimately what happened is that International Astronomical Union brought astronomers from all the countries together, and they wanted to actually classify and make a common classification for whole astronomy community. So what they said, that we can classify the total sky into 88 unequal divisions, but these divisions will only include horizontal and vertical arcs. In that way, actually, they will segregate this full sky, and each of these areas. So now there are 88 areas. These areas are constellations. So each of these areas will contain majorly the figures which are commonly perceived by all the cultures, like Orion or Taurus, like that. So there are 88 constellations, out of which 12 constellations have a special status because our sun and solar system are passing through those. Means projected image of the sun passes through those constellations in the background. So they are called zodiacal constellations, and other constellations, 76 constellations, are called non-zodiacal constellations. So that is about constellation. Then if you go on seeing the stars, you will see that sometimes some stars appear actually as a double star. It may appear as a single star when you look at it unaided, but if you look at it through a telescope, it may appear as a two stars which are very close to one another. Now that is a double star. So a double star can be of two types. Sometimes it may happen that two stars are very far away distance, but along the same sign of light of means line of sight, it appears as a double star because it appears in a very far away distance. It appears in the same plane. Or sometimes what happens is that one star moves around the second star, and like a binary star, and you see a double star in that way. Apart from this, we have clusters, a group of stars which are either loosely packed, like this one in the picture you are seeing. This is called an open cluster, or tightly packed. They are gravitationally bound and move as a unit. Though they are also moving within that cluster, they are not rigidly bounded, but as they are more tightly packed compared to the previous one. So they are called globular clusters. Okay. And then there are volumes of gases when new stars are getting formed. And this is the famous Orion Nebula, which is located in the constellation of Orion. If you take a camera, DSLR camera, and if you image the picture, you'll get exactly similar picture. And if you actually stack the image and process the image, similar colorations will also come after processing. So it shows that the colors represent how much the temperature distribution is there, whether hot stars are there, blue color regions are very hot, red color regions are cooler regions, dusty regions. So these all gives a lot of information about. So these are the nebulas. So this is an emission nebula. If a star is located inside the volume of that particular gas, then it emits due to its high energy received from the star. It is called an emission nebula. Certain volumes of these gases are near some bright stars, so it reflects the light from that particular star. So it is called a reflecting nebula. And then there are certain volumes of dust and gas which blocks the light behind them, so the full thing appears as a sellout. So that is called as a dark nebula. So these are the dark nebula. This is an Horsehead Nebula in the constellation of Orion. So this is the dark nebula. And though this particular image is called a nebula, planetary nebula, in the strict sense it is not a nebula, but it appears like a nebula. Here what happens is that if a star actually, as it evolves, it erupts. And it erupts and throws out some of its matter in the outer space, and still the matter cannot fly away just as it is thrown out. It is still attracted by the gravitation of the star, and it is bounded around the star and slowly dissipates. So the region is like a planetary nebula. It appears like a volume of gas surrounding a central star. So people have named it as a planetary nebula, but in strict sense, it is not the similar type as we have seen emission and reflecting nebulas. This particular image is very important in the sense that if you see the, sometimes if you are in a very good location where you have less light pollution and the sky is very clear, you will see that whitish patch passing through the sky in a band. So that is actually the region of the Milky Way, where actually you see that lot of means whitish patch indicates that there are so many stars that our eye cannot resolve. So that is towards the center of our galaxy. Galaxy means all the stars, all of our stars which we see individually around, they all belong to a big cluster of stars which is called a galaxy, huge collection of stars which is called a galaxy, the galaxy or the Milky Way galaxy. And a part of the Milky Way, since we are located inside the Milky Way galaxy, when we see the projected image of the central part or the other regions, means depending on the density of the stars in that particular region, it appears as a band. So this is actually that Milky Way band that you see. So as I spoke of galaxy, the galaxies are of several types. Like there are elliptical galaxy, there are spiral galaxy. Now this is a spiral galaxy. There is a central bulge, and you can see these spirals coming out. And then there are other classifications also that we will be seeing as we discuss something else also. So some important points if you are planning to observe the sky is something like this, that when we model the stars, when we model the sky, what happens is that we take our sky as a hemispherical bowl in which star, this is the model, this is the abstract model through which actually astronomers study and they define their reference circles, coordinate systems, they study the dynamics. So that is called the celestial sphere, in which Earth's equator is actually extrapolated and then it curves the sky, imaginary sky or the imaginary sphere in a great circle which is called the equator. Similarly, the projected image of this sun as it moves through the sky along from 1 year. For one particular year, if you just put the points and then you project that particular plane, so that is called the ecliptic plane, and this particular model is called the celestial sphere. So by using the constellations, you can locate one. Actually, our Earth, we are located on the surface of the Earth, and our Earth is tilted, and it is tilted, and it has an axis of rotation. And if a star is located along the axis, it never rises or sets. And that is our pole star. And you can locate the pole star using certain constellations. Like this is one of the constellation called Big Dipper or Saptarishi. And if you join these two, Dubhe and Merak, with a line, it moves to the pole star. Similarly, if you have a Cassiopeia constellation here, you can, if you identify those, if you bisect this wider triangle, you can land up in the pole star. So these things will become clear once you have a sky observation program and you learn how to identify the constellations in the sky. Then you will enjoy all this fun of actually locating the North Star and all those things which are seen in the sky. So local sky has a lot of definitions involved in it. Like they have something called a meridian, which actually is the north-south direction great circle, and then horizon where actually our land seems to cut the sky. So all these definitions are interesting, but usually you will learn more about when you study deeply into the subject. So similarly, if you place a camera actually along that pole star and if you keep it open for a long duration of time, what happens is that as the Earth rotates, the light, the stars move in the plate, and it will form a semicircular path as you are seeing here, and then it will form these lines as you are seeing those lines. So like that. So some of the stars are rising and some of the stars are falling. So some stars are always there in the our sky. These are called circumpolar stars. Some stars rises and sets. Some star never is visible from a particular location. So depending on their location in the sky and the inclination of the earth and our location from where we are observing it, so that the altitude of the place is matches the latitude of the pole star. With that, all those things, actually we can see some stars from certain locations, some stars we may not see. And these are some of the guidelines through which actually you can measure the angular measure of the sky. As you can see, these are some of the angular measures. So with your hand, you can have 1 degree, 5 degree, you can measure the locations in the sky. As I was telling you about the zodiacal constellations, all these, some of the constellations are there. This is the Earth and this is the Sun. We are moving around Earth, and then we see this Sun in the background of certain constellation. The Sun appears here. When our Earth is here, we see the Sun along this. The Sun appears here. So all this location of the suns, if you join together, we get a plane, which is called ecliptic plane. So, or ecliptic, that particular path is called ecliptic. So that gives us a geometry of the sky, the model through which we study astronomy. And this is a sky chart, which you can get it from your internet, and you can refer to it to study the astronomy as seen. So all these things are the different types of sky charts which are available, which are accessible through the internet. And this is what I was saying about the pollution, that is the light polluted sky and the places where it is not polluted. You see the number of stars are more in a place which is not polluted. And this shows, actually there are some numbers written here which shows the measure of the brightness of the star as it is visible from a particular location. The higher the number, the fainter is the star, and the lower the number, actually the brighter is the star as is visible. So this is called the faintest star which is visible from a particular location is called limiting magnitude, and in general these numbers are called apparent magnitude. So there is one more magnitude which is called the absolute magnitude, which is when you place a star at a particular distance of 10 parsec. Parsec is a unit in astronomy. We have to explain it more, that I will not do now. So there is one more concept as absolute magnitude and apparent magnitude. These are what you see from the surface of the earth is an apparent magnitude. So that's what is about astronomy part. Now I will just go and give you glimpses of the astrophysics part. So everything that we see in our sky, everything that we know today, we know it through some of these instruments. These are called telescopes. And there are two types of telescopes, reflectors and refractors. So the reflectors and refractors. All this started in 1609 when Galileo Galilei constructed his first refracting telescope. You can see the picture of the refracting telescope which he has constructed and saw the sky. And then he saw a lot of things which revolutionized. Actually, the story went like that Galileo, though he has made his first telescope, but he was not the discoverer of that particular instrument. This was done by a person called Hans Lippershey. He was an optician, and he actually had a lot of lenses, and accidentally some children has taken some lens from him, and they showed him that with a unique combination, the cross of a church is appearing nearer. So he made an instrument using that idea, and then he gave it to his military general to locate the ships of the enemy which are coming to attack. But then what happened is that this news was actually heard by Galileo, who constructed a same thing, but he didn't use for military purpose, and he saw the sky. And there lies the different scientific outlook, and today we know that astronomy has developed due to that particular thing. So as I said you that he observed the phases of the planet Venus, the Saturn, as it is seen, Saturn, and he has drawn. These are the drawings of Galileo Galilei. He could not understand the ring pattern. It took a lot of time to understand. Then he saw the projected image of the sun, and then actually once the telescope got constructed, people started actually making bigger and bigger telescopes. So best telescope constructed was by Christian Huygens. Using his telescope, he has actually in 1655 discovered Titan, the largest satellite of Saturn. So within few years, actually, people also understood through painstaking observation about the ring system around Saturn. So that is also because of this telescopic observation. And people, Huygens also actually watched the moon and Mars and all these areas, no, these polar caps, how they are expanding and contracting with time. All those things they have observed and they have actually photographed. The first reflecting telescope was done by Niccolo Zucchi, but it was actually much more refined by Isaac Newton. And reflector telescopes are much more better than a refractor because it has no aberrations of the lenses, and it is easy to make, and it is not so heavy. There are a lot of plus points of the reflector telescope. So Newton made the first reflector telescope, and on 18th century larger mirrors were made and cast by William Herschel. He was a musician by profession, but he loved astronomy. He constructed his own telescope, and after constructing his telescope, he observed the sky with his sister Caroline. And then in 1781, he discovered a new planet called Uranus. So he was actually William Herschel, who is also the father of infrared rays and infrared astronomy. Then I spoke about Orion Nebula. So they are very, though they are nebulas, gas giants, they are located very far away and they are very big. So see, light travels in space, and one of the units of distance traveled in space is light year. That is the amount of distance covered by light in 1 year. So it is around 1.5 trillion kilometers. And now this particular nebula, the Orion Nebula, which is also called NGC, New Galactic Catalog. These are some of the catalogs through which actually these nebulas are made. So it is an entered, this is the number against which this catalog enters this object. So there are a lot of objects which are entered. And M42 is the Messier 42. Same object has various catalogs like NGC-M. And this is located at around 1,300 light years away, and its span is 15 light years. So it's a very big object. You can see similarly Whirlpool galaxies. So they started revealing using better and better telescopes. So telescopes, the largest telescopes, refractor and reflector getting formed in 1897. People constructed, those who had lot of backup, financial backup and all, supported by industrialists. Yerkes Observatory was supported by big industrialists, and they constructed 1 meter big lens, and in Yerkes Observatory in 1897. Then reflectors were also getting constructed. Today we have a very big reflector. We have we will show you the pictures of today's reflector. But then during as it was going on, people started. George Hillary Hale has built a 1.5 meter reflector, which was because these telescopes should be kept in a location which is free from. There are certain criteria for making an observatory. It should be atmosphere should be calm there. There should be not dust particles. Lot of things. It should light pollution should be less. So like that, they have this particular thing. He has built in certain Gabriel Mountain in San Gabriel Mountain, Mount Wilson at San Gabriel Mountain. And then we have the great, nowadays the Great Canary Telescope is considered to be the largest telescope. Bigger, extremely large telescope is also getting built, which is bigger than this, and its diameter is 10. Now Great Canary Telescope diameter is 10.4 meter, but its design is separate. That I will speak about it. So there are different mounts for a telescope as you can do, and this was 2.5 meter hookah reflector telescope. You can see how gigantic structure it is. It is not like the common telescope that you see in the science centers and planetariums. And then using all these things, actually, George Hillary Hubble, this Edwin Hubble, who was a lawyer by profession and who ultimately turned to astrophysics and did his PhD in astronomy and astrophysics, found out that actually the galaxies are rushing away from each other. So what does the rushing mean? So it means somewhat like this, that the space is getting stretched, and as a result of which actually the galaxies are moving away from one another. So this is the way actually the Hubble's expansion or the universe expansion was discovered and explained by observing the redshift of the galaxies. So to understand it, we can see it somewhat like this. We can visualize it somewhat like this, that if you see, these are the objects present on the sheet, and if the sheet expands, actually these objects are also moving away from one another. So this is how actually Hubble expanded and explained his observations, and this is how actually it was discovered that our universe is expanding. Now, as I was telling you about 1.4 meters, then we said about 10.4 meters. Now that they are the instrument, because unless you have detectors and instruments, how can you observe more fainter? Because you have to observe stars or objects which are fainter, which have less pollution, so we can gather more information. So bigger telescopes have a lot of problems. You can't make a single bigger mirror out of it. So bigger mirrors had lot of corrections to be incorporated, and the concept of active optics was adopted. And in that, actually, what happened is that bigger mirrors were segmented into honeycomb structure, smaller mirrors. These are all each units of mirrors. Either it can be of this type of design or this other type of design, and then each of these smaller segments were actually connected with some actuators and some motors and all to actually tilt to give an appropriate pressure to bend these mirrors so that they can make away for the optical corrections required, and ultimately you get a proper image. So these, you can see how big are these mirrors and how they are getting constructed. So the Keck telescope was having a 10-meter telescope. It was once upon a time the biggest telescope, but Great Canary telescope is now, as I have said you, that it is the largest telescope in the world. So Keck telescope design is shown here. You can see that there are two telescopes, and light is gathered from both the telescope, and ultimately the signal is brought and fed to a common control, and their signals are added to get a better image of the objects. So one more thing people like to do is astrophotography. Now they can photograph the sky. Okay, this is actually amateur hobby. Lot of engineering students, lot of school students, they indulge in these types of thing. If you have a DSLR camera and a telescope, you can actually do a lot of photographing. So CCD cameras are used for photographing, and you can see there, so there are filters with which actually you can do photographing. So today's astronomy is not only limited to actually visible astronomy, which is only a part of the ultra means our intermagnetic spectrum, but we know we have detectors from, because from ground actually we can see only radio and visible astronomy. Other astronomies, for that actually, since our atmosphere absorbs them, we have to go beyond. So we are either with balloon or spacecraft. So these are this is the radio telescope, and this is the radio image of the sun. So radio telescope, as you might have known from the dish antenna shape and all, but they are much bigger, gigantic in structure. So they collect the radio waves. So this is the functioning of the radio telescope. The object of interest is here, and the radio waves are collected at the feed, and then it is sent to the control room, and where it is analyzed. So we have in India the GMRT radio telescope, Ooty radio telescope nearby, which are working on similar lines. So these are the optical image, infrared image, and the radio image are shown of the giant radio galaxy. You can see the Cassiopeia A. Even with these radio telescope, people have found out the cosmic microwave background radiation, because it is found out that actually the universe started with a big bang, in the sense that it exploded, and initially the energy or the total energy was concentrated into a singularity, a point, and ultimately that expanded, that became this energy got distributed. And today, if you take the radio telescope and locate it at any direction, radio telescope, the antenna temperature comes to around 2.7 degree Kelvin, and that is the background relic radiation. So that is actually the cosmic background radiation. That is one of the confirmation proof of actually that our universe started with a big bang. So there are other telescopes which are coming in the pipeline, like we have Atacama Large Array Telescope. There are a lot of telescopes giving rise in a desert environment, so that they get better measure. Then we have the neutrinos of detectors, which also speaks a lot about our sun and stars. Neutrinos are massless and chargeless particles, and if you study those neutrinos, capturing those neutrinos, because they are in large numbers, but it is very difficult to make a detector using those neutrinos. And gravitational waves is recently picking up, because people have detected that gravitational wave, and a new astronomy is getting formed because of the gravitational wave, where massive objects actually they create ripples in the fabric of this space-time, and this is what is called as a gravity wave. So if two black holes come and collide, they generate waves that can be, though they are very violent, but by the time they reaches us, it dampens, and it is very feeble signal to pick up is a challenging task. Then there are other telescopes like infrared detectors, like Spitzer telescope, which is shown here. This is one more telescope, and then Orion Nebula using infrared and optical. You can see that. So with from various wavelengths, if you study, different same object using various level, and we come to know much about what is going inside, what are the mechanisms arranging, so we can make models better and understand it better. So there are different types of telescope, like quantum telescope, like different designs of telescopes which has come up. Chandra Observatory it was made by NASA, honoring our Chandra, Subramanian Chandrasekhar. It was working in the X-ray range of the electromagnetic spectrum. It has given a lot of records. Hubble Space Telescope, known to all of you, it has captured innumerable number of images, and we understood the universe much better using the data transmitted by this telescope. So X-ray, gamma ray, and extremely large telescope, as I was telling you, that this is one of the designs which is under, it is getting formed, and once it is ready, we will have a very big telescope, very big facilities where engineers, scientists, and all the other people can gather data and understand about our universe much better. So before I just conclude, actually, if you ever form to have an astronomy club in your campus, you can have following activities, like you can have the projected image of the sun, and you can photograph, as we have shown you some of the photographs. These are all done in our science center's environment, so you can also do it. These are the photographs taken by of Jupiter, Saturn, Orion Nebula. So all those things you can do it. Saturn's picture, then you can take the picture of the sunspot. Then you can organize certain astronomy drama to understand actually what are the mythological features which are associated with that. You can publish certain journals, departmental journals. You can do certain experiments to understand basic astronomical phenomena. You can organize workshops in your campus, and you can have astronomy demonstrations. You can visit observatory as a group of team visit from your club, as it is done here. Then telescope making is one big activities which you can do. Observation programs you can organize in your locations. Eclipse observations. All these things can be done at a very easy rate, and you can actually do a very good service. So you can have a good and learning environment of this astronomy and astrophysics, and it will be highly enjoyable for you to study this science, and maybe some of you will get interested and take up a career fully dedicated to this particular field of study, because instrumentation is one of the things which are picking up, and which actually people can take up as a passion. So you are saying that astronomy lectures, star parties, so a lot of fun and things are involved using these things. So with this, I think I will end up my talk. If you have any type of questions, you can ask me. Yeah, I am done. I am finished. Hello.
Yeah, thank you, sir. Any queries?
Any queries, you can ask me. Any type of queries are there? If there are no questions,
So how can you decide on getting a telescope actually? What step we should look for a simple observation purpose?
yeah, actually it depends on many factors. One is that what type of work, if you want to do for a popular observation or educational purpose, like in your colleges and all, just for observation and observing the object, you can use a 6-inch to 8-inch or 11-inch refracting telescope. Reflecting is better, but refracting is robust. Refractors are costlier. Reflecting telescope, mirror-based telescope are cheaper. But then if you want to do astrophotography, if you want to actually capture certain images and then do processing and all, you require certain drives so that the telescope rotates with the object. So you require a more sophisticated telescope. So it depends on your budget. Now, if you have say 1 lakh, you can spend from your college authorities, then you can get a good robust telescope. But then for normal purpose, you have telescope ranging from 15,000 to 20,000. Also, you get a telescope, a reflecting telescope, and around 30,000 you get a 4-inch refracting telescope that you can use.
Okay, thank you, sir. So similarly, when I look at the slide, I could see that night sky. I could see a bright thing. Is it Jupiter actually? Out of curiosity,
Yeah,
I'm asking.
yeah, Jupiter.
Okay. So why is that visible regularly? Because others
Actually,
are not. Yeah,
yeah, complete your question. I
others are not visible at a regular interval, but we can see Jupiter regularly, right? So what's the reason for that actually?
You can't see Jupiter regularly. There are
No, but
certain observing
frequently, yeah.
windows actually. Nowadays, you are seeing Jupiter.
Yeah.
Sometimes it will be appearing in the daytime, I mean, in the early morning. Sometimes it is appearing in the evening time. What happens is that, see, Earth and Jupiter and all are moving around the Sun. So, based on
Okay.
the location of the Earth and other two planets, Jupiter or Saturn, their visibility in our sky is decided. So, it depends on during which year and which month. Since Jupiter and Saturn are far away from us, and their orbits are very high, so their changes are actually long duration change. With
Okay.
the change, appreciable change, Earth will move faster than that. So we will see, say, evening time Jupiter for 1 or 2 years, and then again it will go to morning time. So that depends on actually where is the Earth and where are those planets at that particular time in their orbit. That
So
decides.
can we see satellites on sky with any like Ganymede or Titan or something like that? Can we see that?
Yeah, you can.
Ganymede.
Yeah, you can see for that actually you should there is a site called heavensabove.com. Heavens
Okay.
Above. I will type it here. HEAVENS Heavens Above dot www, of course you have to append it. So if you type this heavens dash above.com, you can see the satellite timings, which day from the, because that will be asking you to locate your latitude and longitude of the place from where you want to observe. So at that particular place, which all things are visible, which all satellites, artificial satellites are passing in the sky, you will get the timings. So you can actually record those timings and then you can observe that. You will be definitely seeing that.
Okay. Thank you, sir.
Good evening, sir. Sir, few words about that artificial sun, nuclear fusion based.
Yeah, artificial sun. Now, so these are actually some concepts which people think, but you know that sun is it's such a big and so much energy is getting produced. So making an artificial sun which will light, people also started thinking about sending satellites with lot of mirrors attached to that, so that it will illuminate the sky during night time also, and we will get like a natural light environment. So people were thinking, but maybe as a policy it may not click, or it may be so costly that it may not work out. And making an artificial sun is actually next to impossible, in the sense that so much energy no one we can't harvest with our artificial methods. So people are making models, but then they remain as models only. Practically it is very difficult, it is sometimes impossible to do all these things. Did I answer your question?
Yes, sir, China is doing with that artificial sun,
Yeah,
so
they're
that's why.
trying. Maybe that it is actually, the thing is that it may not be like the normal sun. It may be, as I was telling you, know that it will not be using the same type of nuclear reactions. They may have certain type of mirror mechanism to illuminate a certain portion of the area above which that satellite will locate, and that light will be reflected. So those things they are trying, not the nuclear fusion type of things.
Okay, sir. Thank you.
Um,
queries are on chat box.
Yeah, what if the universe is not isotropic all around? See, universe is isotropic is a principle which is called a cosmological principle. Okay, so you will not see that same number of stars are scattered in the sky everywhere equally. But if you see from a very long perspective, and if you count the survey, the number of galaxies distributed, you'll see overall it appears isotropic. So isotropy is a principle of the nature that is called the cosmological principle. So by your question is that Anirudh K has said that what if the universe is not isotropic? It is something like what if the gravity doesn't exist? Now that doesn't work. Isotropic means it started with singularity and it is not fully similar, because everywhere if it is same mass, then concentration distribution will not be there, new galaxies will not get formed because everywhere the mass concentration will be same. So those are very hypothetical. In perfect logical sense, nothing would have happened if it is fully isotopic. But in general, what is happening is that if you, from a cosmic perspective, from a very large distance, if you imagine the distribution of the galaxies, it appears isotropy is there, and that is the reason actually it is saying that equal number of galaxies are formed in each epoch, and it is going on for expansion is happening. So that is what is meant by the cosmological principle, and that is the thing related to the isotropy. That is one thing. And then one more question is given by Partha K. Jain. It is saying that what is a parallel universe, and could there potentially be one that could be uh, okay, something of everyone on the earth? See, parallel universe are mathematical concepts. I mean, so they are the concepts which are outcome of our general theory of relativity. So what it says that it is possible to have multiple universe, and there may be other universe which are existing presently. But then see, in our universe itself, we can't go from one location to another location because of the velocity constraint, because nothing can move greater than the speed of light. So if there is a parallel universe also, people say that you can make a wormhole and you can go through gravity, but they are all much like, no, they are all much like fictions now, though physically, theoretically, everything is fine. If you might have seen the film called Interstellar, you will understand that, see, many things are physically, as per scientifically feasible, but practically it is very difficult, technologically it is very difficult to implement. Okay, so parallel universe is a concept, mathematically consistent, logically true, but ultimately, so these are more like science fiction rather than they have any relevance. Any expiry of the satellite? See, satellite depends on type of a fuel. No, they have to have, they energize their own equipment, and there is a lifetime for every satellite. No satellite can work throughout for a very long period. So as a result, what happens is that uh, there are expiry, but then they form the space jumps. No, there are, for example, all the missions. No, they have a lifetime. They don't work for lifelong mission. Voyager, which a lot of our satellites which we have also said, it doesn't work for lifelong. So what happens is that we have to there are space dust form, but then space is so vast, so it is up till now there is no such problem, but maybe in future we will have a problem. Why does comets and meteor repeat? As I told you that meteor, the logic of how meteor is seen every month is that when a comet moves around in its orbit, it leaves dust particles in its orbit. So as the Earth passes through the dust particle, it attracts, due to its gravity, these particles inside its atmosphere. And these particles, when it comes through the atmosphere, it gets heated up and lights up. So why it is regular? Because Earth's periodicity is regular. It is moving in the same orbit every year. So every year it crosses those paths, and so every year we see those dust particles, and those are the windows of these meteor showers. Uh, okay, so I think that answers Harishankar's question. And next is that feedback form. How is the signal from a telescope processed? So signals actually, these light signals are ultimately converted to digital signals or electrical signals, and they are stored as in coupled charge devices as charges, and then they are combined with lot of, as I showed you, that multiple array telescopes are used and signals are combined together to make the signal strength higher. And once the signal strength is higher, this image is formed, and then the image analysis is done. Image analysis is a vast topic. There are a lot of process. Like if you, for example, in our campus, people have done projects using the measurement of the shadow of the lunar mountain, and ultimately they could measure the height of the lunar mountain. So with this, actually, what happens is that you have to get multiple image of that lunar mountain, and since the images all may not be, the single image may not be good, you have to get a consolidated stacked image. You have to stack it with a stacking software. There are different types of software, like Registack software and all. So you have to stack the image, and ultimately the image is processed by various other software like Astronomy, Astroimage, or and you use MATLAB for certain counts. All these things are possible using various softwares, and then you make the ultimate calculations using certain calculating, like Python people use. You can use certain image processing software and calculating, and people you can do the processing. It is not a single affair, it's a lot of multi-stage affair. Image acquiring is the data collection, processing is a long time affair, it takes certain time. So that was one thing. And when does the space begin? It's actually, the straight answer is that it started with the singularity. So when the Big Bang started, space also started getting formed. Like now, if you have two chairs, three chairs, and if there is something in between three chairs, that is called space. So as the chairs are moved apart, the space also increases. So like that, Einstein explained in his common language explanation of the general theory of relativity. Ideas and opinions. If you read through that book, you will understand. So that is actually how the space began, and as the matter is moving away from one another, newer space is getting created. So that is. So is there any another universe inside wormhole or the black hole? So black holes are actually type of concentration of the wrapping of the space time, and the matter of the black hole is under debate. Actually, nobody knows what is exactly there. People understand a lot of things about it. Evaporates, it will have a certain charge, it will be spinning, but what exactly the matter the black hole forms, nobody. So and wormhole and aura are mostly, as I told you, they are concepts. They are not in physical reality up till now. So one thing is that, see, black hole collides and gravitational wave is formed is a reality, because we have detected those and we have modeled those. But then now wormhole travel and all are not reality, so we can't speak about that as far as the proper science is concerned. Then Suraj just said, sir, will there be a fraction of correction? What is friction in reaction wheel of a satellite? There is will there be friction in the wheel of a satellite? Is it decreasing every year of the satellite? So what you mean is that, I think what you wanted to say me is that that if there is a because in the space frictional force only thing means that there are some dust particles or there are some objects which are actually striking that particular component of the satellite and which are altering its dynamical properties. This can happen. Okay, that can happen, because otherwise space has no big object, and space is actually having it is empty space, it is called. It has no matter, much matter density is very less. But then that is not a major factor for most of the snags which are faced by our satellite. There are other reasons for which actually a mission fails or a mission lifetime is suddenly shut down. So that may not be the main factor. I know only that much. Any other questions? I think I have answered whatever is there in the chat box. So, anybody else? So Suraj is asking what I meant is what reaction wheel is rotating in high RPM, will there be a friction in its bearing? So friction, whenever two objects rotates, see, frictionless bearing is again idealistic concept. Friction will be there, but they are minimized. The materials, type of material used, they are space compatible materials, so they are minimized, and in that sense, they are nearly perfect and not exactly perfect. There will be friction, but very minor friction. So I think that's all.
Now I welcome Arya R from EC to say vote of thanks.
Hello, am I audible?
Yeah.
Good evening to all. It's my pleasure to propose vote of thanks. At first, I would like to thank the speaker, Mr. Jayan Kanguli sir, for this wonderful session. Thank you, sir. And I thank Dr. V.S. Gopal sir, Chairman of Ahalia Group of Institution, for his valuable presence. Thank you, sir. I thank Dr. P.R. Sri Mahadevan Pillai sir, Principal of Ahalia School of Engineering and Technology, for his valuable presence. Thank you, sir. I thank Dr. Krishnakumar Kishore, Vice Principal and IEEE Student Branch Counselor of ASSET. Thank you, sir. And I thank all the HODs and faculty members for your participation. Last but not the least, I thank all the participants for your participation. Once again, thank you all for your participation.
Thank you. Okay, so I log out.